Hello and welcome to IGPP Expert Talks. I'm Heena Goswami, editorial consultant with IGPP, Institute for Governance, Policies and Politics, New Delhi. In our ongoing series about artificial intelligence, its various aspects and impacts on society, today we are joined by a very special guest, Dr. Kush Varshney. Dr. Varshney is a distinguished research scientist and senior manager with IBM Research at Thomas J. Watson Research Center, New York, where he directs the Human Centered Artificial Intelligence and Trustworthy Machine Intelligence team. Welcome to IGPP Expert Talk, sir.
Yeah, thank you so much. It's my pleasure to be here.
So you have authored a book titled Trustworthy Machine Learning. Could you please elaborate a little on what do you mean by trustworthy machine learning, and how does the aspect of trust remains relevant to the the debate on AI?
Yeah, sure. I like to kind of think about trust and trustworthiness just in the context of two people. So let's say you're trying to hire a carpenter to work on your house or something like that. And the question arises, what makes that other person trustworthy? And people have kind of thought about four different attributes that would make that other person trustworthy. So the first is that they're competent at what they're doing, so they're able to do what they say. They're credible at it, and so forth. The second is that they're reliable. So in different conditions, different settings, that competence sticks around, and they're still able to do what they say. But things go beyond that. So the third attribute is that you're able to communicate back and forth with that other person, that you're able to understand what they say, they understand what you say, that you have some level of intimacy and communication and so forth. And then the last fourth attribute is that that other person is working towards goals beyond just their own. They're selfless. They're working for you and so forth. So all of those together are what we mean by trustworthiness. But trustworthiness isn't exactly the same as trust either. So when we think about trust, someone can not be trustworthy and you still trust them, and the opposite as well. And there's all sorts of reasons for that. So trust is the vulnerability that you have that even without being able to control the other person, that they're going to do the things that you want. And in the context of machine learning or AI, these are exactly the same things that we're looking for from these artificial intelligence systems. So we do want them to do the job, to be reliable, robust, to be explainable and interpretable in the way that we can understand how they work, and also take our values into account so we can instruct them on what we want, and then having the goals beyond just the system designers or anything like that. So all of that together is, in my mind, the trustworthy AI. And I know we're going to get into more details of explainability, fairness, and other things, robustness. So I look forward to diving in. Yeah.
As you have been involved with development of AI related technology, I want to ask you what responsibilities do technology professionals bear in ensuring trustworthiness of AI system, and how can they actively ensure that trustworthiness of the AI system is ensured?
Yeah, it's a good question. So when we think about it, what is the responsibility of the technology provider, the creator of the tools, the developers that use those tools in applications? I think the biggest thing that I like to emphasize is just that uh, the technologists slow down and don't take shortcuts, in the sense that a lot of the things that we talk about in trustworthy AI, fairness, explainability, robustness, these sort of things, they're kind of obvious once you start and pause and think for a second. So it's not a question of like no one will argue that these are bad things to do. The only reason that we don't do them often is just we're rushing ahead. We want to show quick results, and then we don't spend the time to step back and look at considerations beyond just accuracy of these models and these problems. So once we slow down, we can say, oh, yes, this is a consequential domain. Yes, I should be considering things that go beyond that quick number or is often looked at, and then institute those. And they are the things that actually take us into a place where we can operationalize these technologies in consequential domains. So it is actually the thing that is required so that we can put these things into practice.
One term that has repeatedly come up in our discussions, and
Hmm.
that is, part of the debate around AI, explainability of the AI models. So
Hmm.
you have led teams on developing AI fairness tools like AI Fairness 360, AI Explainability 360.
Hmm.
Can you explain how the technologies that you have worked ensure the fairness and explainability of AI models? And in the era of large language models and complex models that use trillions of parameters and data,
Hmm.
is it possible to have explainable AI?
Yeah, so yes, we have worked on these open source toolkits, AI Fairness 360, AI Explainability 360, and some others as well related to uncertainty quantification, adversarial robustness, transparency through fact sheets, and so forth. And these are Python toolkits, and so any working data scientist can drop in these different algorithms, different metrics into their natural workflows. And when we talk about fairness, the main idea that we're looking at is mitigating unwanted social biases, because it is possible for any decision making to institute systematic sort of relationships and discrimination that is not wanted. So it could be with respect to age, gender, religion, race, caste, these sort of things. And so when we look at it, what we want to ensure is that certain privileged groups aren't getting the systematic advantages and unprivileged groups aren't getting the systematic disadvantages. And the way to measure it, there are many different metrics that are called fairness metrics. They depend, which one is the right one depends on several factors related to kind of the worldview that you're in, what kind of biases there are, and so forth. But once that's been defined, these toolkits, the AI Fairness 360 includes metrics for measuring that. But the more important thing is a bunch of algorithms. I would say maybe by now, I think there's 15 or 20 different bias mitigation algorithms in the toolkit. And what they're trying to do is break the statistical dependence between these protected attributes like the race, gender, religion, and these sort of things, and what you're making a prediction about. So that could be should someone receive a job? Should someone go to prison? I mean, all sorts of different things. And so if they're independent of each other, that means that the model isn't going to be biased. So that's exactly what these algorithms are aiming for. And then the explainability goes in a different direction. So with explainability, with AI Explainability 360, we have a bunch of algorithms that take into account the fact that humans have different ways of explaining. So right now, like when we're discussing different topics, I can use analogies to explain things which I did with the carpenter before. I can be more technical, like I was right now, just with the fairness. So we have lots of ways of explaining. And by doing so, we give a whole sense of what it is that is going on inside the machine as it's making its decisions. And depending on the persona of the consumer of the explanations, their goals, their other things, then we do want to use different ways of doing so. So AI Explainability 360 pulls together many different ways, some of which we invented at IBM Research, some from the external different labs and so forth, and provides those all those different ways. So it could be through what we call contrastive explanation. So what would I need to change in the future so that I do receive the job? It could be through what are other similar people who did and did not receive the job, so that I can see what was required and so forth. So there's many others as well. So all of these are encapsulated within AI Explainability 360. And coming to the last point that you made with generative AI, the large language models. So to me, when we're talking about generation, the thing that we want to understand isn't necessarily how the model works, the trillion parameters. It's really the question of where did the information come from that was part of the output. And that's the problem that we call source attribution. And to me, source attribution is the new explainability that we want now in this world of foundation models. So if we can trace back that these facts, whatever it is, whether it's Lal Bahadur Shastri being the second Prime Minister of India, if we can trace that back to knowing that it was from this source, this training data or this prompt or this fine-tuning data, that information led to that piece of information in the output, then we're much more satisfied by the fact that how these models are doing their thing.
Algorithm also play an important role in ensuring the effective deployment of AI technology, right? So how do we ensure that algorithms also, other than just data that is being fed into the AI technology, how do we ensure that algorithms are also socially responsible? What constitutes socially responsible algorithms? And how can they play a role in mitigating the potential harms that are generated by AI systems?
Yeah, I think social responsibility is the starting point for a lot of this discussion of trustworthiness and AI. So the main point I want to make is that kind of going back to that fourth attribute of trustworthiness that we were talking about before. So we should be thinking about helping people in a way. So people who can't help themselves. I mean, that is what social responsibility at the end of the day is: helping people who can't help themselves, giving voice to people who can't speak for themselves, etc. And AI is, I mean, taking over, I mean, or being augmented in a lot of decision-making processes, a lot of processes of how the world is progressing. So the way we need to approach AI development is to be participatory, not to be paternalistic in the sense that, like, I know better than the person who's being affected by these technologies that what should be done, but actually engaging with them, asking them, understanding what their concerns are, and then building and co-creating actually with them what the technology should be. Because if we kind of or have this hubris that, oh, I know what needs to be done, I'm a technologist, I should be able to do this, then we're completely missing the point. So the entire kind of AI for social good movement, there's kind of different ways it can be done, but the best way is by actually working with people on the ground, people who are truly involved with uh, that deployment among the populations, the communities in which these things are going to be rolled out. And not just NGOs, but the actual people. I mean, the people who are the affected users through this. Yes.
There's a perception that tech professionals have limited control over AI system once they are allowed to change in real time. Could you
Mhm.
clarify this aspect a little bit and shed light on the level of control that can be maintained?
Yeah, so first thing I'll say is there is a misconception that a lot of the AI technologies do, I mean, learn on the fly. So that is actually quite rare. So most of the time you have a deployed model, and if it's going to get updated, it's very rarely, only like once in every few months or something like that. Once there's additional training data that's collected, and then someone actually says, yes, let's retrain the model and make it better or improved or whatever. But the point is that yes, sometimes there is kind of this self-learning that's like ongoing and so forth, but the control that we need to have is what we would call governance, AI governance. And there's many sort of technologies we're working on that help organizations with that governance. And it includes a variety of things. One is having transparency throughout the entire life cycle. Where did these things come from? What were the choices made? can we put guardrails on different tests that we conduct throughout and ensure that different things are getting triggered if the system goes outside of those bounds. And all of that governance kind of includes feedback loops and ensuring at every point that we're kind of testing, being test-driven, auditing, red teaming, all sorts of things as part of this, and then bringing that back, whatever things are deficient at, that says, oh, this is something that needs to be improved, or any harms need to be protected against, and so forth. So just the fact that, like, again, not taking shortcuts, so having an AI governance process as part of the overall system is the main thing.
In a developing country like India, when
Mhm.
we are starting to use AI, it's being deployed in various sectors. There are several challenges to it. One is to ensure that the technology is continuously being innovated, put to socially good use, but also to ensure that there are guardrails to make sure that the potential harms are being mitigated. So there's a lot of discussion about capacity building for policymakers to ensure that balance is maintained. What key aspects do you think policymakers need to understand before attempting to regulate AI, and what approach should government take in regulating AI?
Yeah, so I think one thing that, I mean, both policymakers and technologists need to better understand is how each other actually do their job. Because as a technologist, I actually don't know all of the ins and outs of what policymaking involves, what the constraints are. And many technologists kind of believe if technologists just could be the policymakers, then life would be better. But that misses the point of the fact that, I mean, how government works, how policies are made, there's all sorts of things that go on that are their own sort of expertise and so forth, right? And same way on the other side, if policymakers can better understand the way technology kind of develops, what the incentives and motivations are, and not be afraid just to spend a little bit of time going through some of the details of how these things work, I think all of that bridging will be helpful. And then in terms of like what are the policies where we should be going forward, one thing I believe quite strongly in is precision regulation. So when we think of AI, it's a general purpose technology. It's not that we regulate wheels in general, right? We regulate the use of wheels in a windmill, as tires in a car, and different machines and so forth. It depends on the use of that general purpose technology. And the same applies to AI. So it's not a question of AI in general, but when we use AI in lending, in hiring, in whatever sort of application, that's where the question comes up. And there are all sorts of existing policies and laws and regulations that already apply to these different sectors. And just the fact that AI is coming into it doesn't mean that all of the laws and other things that have applied from the very beginning are no longer applicable. So if there is a law that prevents discrimination in hiring or in lending or these sort of things, just the fact that now AI is part of it or will be doesn't mean that we can now forget about the fact that that those policies have already existed. So making sure that existing policies, existing sort of thoughts around these things don't change just because there is one component that is changing the decision-making process. The overall sort of regulation should remain.
Thank you so much for giving us your valuable time and
Yeah.
insights into AI technology.